Welcome back to my channel. Today we are going to learn something about calculation based on chemical equation. So first of all, we should know a chemical equation is a symbolic representation of a chemical change, and a chemical equation does not only shows the qualitative information, it also shows a quantitative information. So children, first thing I want to tell you that a chemical equation, or better we can say a balanced chemical equation, is an account of a chemical transaction. So whenever we write any chemical equation, it gives us different information. It gives us information about the number of moles of each reactant and each product. When we balance a chemical reaction equation, then we write some coefficient, and these coefficient represent the number of moles or the molar ratio. So a balanced chemical equation gives us information about the number of moles of the reactant consumed and the number of moles of the product produced. It also gives us information about the masses of the different reactant and different products. And if the reactants or the products are gases, then it also tells us about the volumes of the gases. Because we know that these three terms, these three quantities are interrelated. When we say 1 mole, its mass is equal to its molar mass. And when we say 1 mole, its volume is always 22.4 liter at STP. So let us try to understand this concept, how to calculate the mass and volume of the reactant and product in a chemical equation, the calculation which is based on chemical equation. Let us take some example to understand this. So I have taken some problem, and by solving this problem, we'll try to understand how to calculate the mass and the volume in a chemical reaction. So first of all, we will see some of the problems which are based on the reacting weight, the weight of the reactant, as well we can find out the weight of the product. So children, now on your screen you can see a problem, a solution of common salt when added to silver nitrate solution yields a precipitate of silver chloride 0.28 gram. Find the mass of sodium chloride in the solution and also the mass of sodium nitrate form. So this problem is based on a chemical reaction, the chemical reaction between silver nitrate and common salt, NaCl and AgNO3. When they react, obviously the product the product will be AgCl plus NaNO3, NaCl, NaNO3 plus AgCl. So let us find out the solution. So first of all, we have to write the balanced chemical equation, and the balanced chemical equation for this is NaCl plus AgNO3 gives AgCl plus NaNO3. It is completely balanced. That means you can see here the molar ratio is given 1 mole of sodium chloride. When we say 1 mole of sodium chloride, then its mass also we can find out. That is sodium chloride, sodium is 23 and chlorine is 35.5. So if you add that one, then you will get the mass of sodium. Silver nitrate also you can find, silver chloride, the mass also, because all these are 1 mole. Now from this equation you can see here we have the mass of silver chloride is given, and we have to find the mass of sodium chloride used in the reaction and mass of sodium nitrate form. So we have to find out the molar mass first. Sodium chloride, as I told you, 23 plus 35.5 is 58.5. Similarly, silver chloride, it is 108 plus 35.5. Sodium nitrate also, we have already learnt how to find out the molecular mass. So it is the sum of all the atomic masses. Now, from this equation, we can see that 143.5 gram of AgCl is formed from 58.5 gram of sodium chloride. This is the information we can get from this equation. Now, what we have to find out? When 0.28 gram of silver chloride is formed from, what will be the answer? 58.5 into 0.28 divided by 143.5. So the answer will be 0.144 gram of sodium chloride is formed. So this is the first part of the question. Find the mass of sodium chloride. Now if you go to the second part of the question, also the mass of, you can see here, also the mass of sodium nitrate. So now the relationship between sodium chloride and sodium nitrate. Okay. Sodium chloride and sodium nitrate. 58.5 gram of sodium chloride forms 85 gram of sodium nitrate. So from this question, how much sodium chloride is used here? 0.144 gram. So 0.144 gram of sodium chloride forms, what we can do? 85 into 0.114 divided by 58.5, which is equal to, if you calculate, 0.165 gram of sodium nitrate is formed in this reaction. So this is how we have to do. First you have to consider the number of mole, then molar mass you can find out for the concerned compounds, and the answer you can write here that 0.114 gram of sodium chloride is present in the solution and 0.165 gram of sodium nitrate is formed. I hope you understood. Let us go to a second example on a problem based on reacting Y. So the problem is calculate the mass of ammonia that can be obtained from 21.4 gram of NH4Cl by the reaction. The reaction is given here. 2NH4Cl plus CaOH whole 2 gives CaCl2 plus 2H2O plus 2NH. So we have to find out the mass of ammonia, and in the question it is given the mass of ammonium chloride used here is 21.4 grams. So ammonia and ammonium chloride, these two we have to see. The solution, you see, the balanced chemical equation first, which is given in the question, is 2NH4Cl plus CaOH whole 2 gives CaCl2 plus 2H2O plus 2NH. Here you can see 2 mole of ammonium chloride. That is 2 into ammonium chloride. If you find out the molar mass, then it will be 53.5. 2 into 53.5. This 53.5 is the molar mass of NH4Cl. Similarly, ammonia, the molar mass is 70. So here 2 moles are produced. That is why it is 2 into 70. Now let us, from this we will get information that 2 into 53.5 gram of ammonium chloride produce 2 into 17 gram of ammonia. So our question is, how much ammonia is formed from 21.4 gram? So 1 gram of ammonium chloride gives 2 into 17 divided by 2 into 53.5, that is 17 by 53.5 gram of ammonia. So 21.4 gram of ammonium chloride gives 17 by 21 into 21.4 divided by 53.5 gram. That can be calculated as 6.8 gram. So the answer is the amount of ammonia obtained in this reaction is 6.8 gram. Let us come to another problem. Now this problem, you see, it is the problem which is based on mass volume relationship. The previous one only mass. Mass of this one is given, mass of the other one we have to calculate. Now the problem is mass of something is given and the volume we have to calculate. Or volume of a gas is given, you have to find out the mass. So the central point here is the number of moles. Let us take this example. Example is find the mass of lead formed by the reaction of 342.5 gram of red lead in a current of hydrogen, and also find the volume of hydrogen built up at STP. So this reaction, if you read the question, then you can find lead formed. Lead is formed from red lead and hydrogen. So the reaction is between red lead and hydrogen. Pb3O4 plus H2 will give lead plus H2O. So first of all, we have to write the balanced chemical equation, which is you can find Pb3O4 plus 4H2 gives 3Pb plus 4H2O. Now children, you can find here 1 mole of red lead, and we have to find out the mass of lead. So 1 mole of red lead gives 3 moles of lead. Okay, one, and also we have to find out the volume of hydrogen, that is 4 mole of. So here we can write molecular mass of Pb3O4 first we have to calculate, which is you can find here lead is 207, 3 lead molecules are present here. This one you can find 3 lead molecules, so 207 into 3 plus 4 oxygen, that is 16 into 4, so total it will be 685. So let me write here 685. Then volume of hydrogen, what is the volume of 4 mole of hydrogen? 4 into 22.4 liter. And what is the mass of 3 mole of lead? Lead, already we saw that the atomic mass of lead is 207. So it will be 3 into 207. Now let us write our information first. 685 gram of red lead yields 621 gram of lead. So 1 gram of red lead, 621 divided by 685. So how much red lead is present here? 342.5 gram of red lead. So 342.5 gram of red lead yields 621 into 342.5 divided by 685. If you calculate this one, then you will get 310.5 gram of. And now we have to find the volume of hydrogen used. For this, from here you can find 685 gram requires 4 into 22.4 liter. So you can see here 685 gram of red lead uses 89.6 liter of hydrogen. So obviously 1 gram red lead uses 89.65. So our question is here, the amount of red lead is 342.5. So 342.5 gram red lead uses, you can find it out, 89.6 divided by 685 into 342.5 liter of hydrogen, which we can calculate as 44.8 liter of hydrogen. So now children, the answer to the question is 310.5 gram of lead is formed and 44.8 liter of hydrogen is used up during this chemical reaction. So I have tried my level best to explain you how to do the problems which are based on chemical equation, and now it is time for your home assignment. As the home assignment, you have to do as many numbers, you have to practice as many numbers as you can. So in your textbook also you can find many numbers, and solve all numericals given in your textbook, that is from exercise 5D question number 1 to 12, and also you have to solve the numerical in the miscellaneous exercise question number 1 to 52. So children, this mole concept, it is depends upon how much you practice. If you practice more, then it will be clear to you. So practice more and more numbers, do all the numericals given in your textbook. Thank you for watching. Have a nice day.